Welcome everyone to our episode 70, and we are beginning a new season, season 4 for our podcast Cultivating a New Generation. It is a new stage in this podcast, and as this is a different version, we are going to implement some new changes in order to give you much more knowledge, science, and information in the next episodes to come. So if you like and resonate with this kind of interactions that we are having in the 5 pillars of health, please help me to share to everyone this information. And in this case, the episode 70, the starting of the new season, is going to be about uric acid link to insulin resistance and liver damage. Such an extremely important topic right now that many people are having symptoms after whether they cursed with COVID or they got vaccinated or they got infected afterwards. Any case you have, you might be having problems with your uric acid and many times also with insulin resistance. So we are going to understand these metabolic links and how it has been damaged, and many of the disruptions come from hormones, and we are going to understand how to heal ourselves in order to repair these kind of damages that we suffer due to this pandemic. So in order to begin with this topic, the article and the references that I use is from the Pergola, is the author, and it's from 2018. The title is Uric Acid Metabolic Syndrome and Atherosclerosis, the chicken or the egg, which one comes first? So we are going to understand all of the science. The journal is Endocrine, Metabolic, and Immune Disorders and Drug Targets. And we are going to begin by defining how uric acid is the final product of the metabolism of purinic nucleotides. What are purinic nucleotides? These nucleotides are like the Lego blocks that are going to build your DNA and your RNA. So they form adenine, thymine, cytosine, and guanine. All of these bases, nitrogen bases, are also called purinic nucleotides. So which is the main component, this uric acid, of cellular energy store, such as also adenosine triphosphate, which is your ATP, or mostly known for that name. And this ATP is your energetic coin in the metabolism of your whole body. So this is the constitutive elements of the deoxyribonucleic acid, as I mentioned, and ribonucleic acid. So they are extremely important. All of these assembling blocks that we are going to use for DNA and RNA come also from the metabolism of these purine bases. So uric acid might be considered a protective factor. Not only is a bad final end product of your metabolism, but it's also a protective factor against atherosclerosis because of its antioxidant and anti-inflammatory properties. But we have to be careful not to be linked with other things in your metabolisms that are going to make it to work as the bad guy in the movie. So on the other hand, uric acid has also pro-inflammatory effects mediated by two main possible mechanisms. One is monosodium urate crystals that can activate inflammasomes, and the other one is radical oxygen species, or mostly known as ROS, ROS, deriving directly from the uric acid metabolic pathway. It is to note that pro-inflammatory actions may promote metabolic disorders. So watch out, as I mentioned, if uric acid is elevated and you have other additional symptoms, such as insulin resistance or any kind of dyslipidemia, then it's not going to be on your favor. So these actions that are pro-inflammatory and these other secondary diseases may promote metabolic disorders such as hypertension and cardiovascular disease. Metabolic syndrome is the clustering of the cardiovascular risk factors, such as central obesity, hypertension, and atherogenic dyslipidemia, which is high triglycerides and lower HDL cholesterol circulating concentrations. What are your HDL? What is that? And what is the triglycerides? Many people know them, but these are three fatty acids linked to a molecule of glycerol that is going to create, they are going to start making the diameter of your veins narrow, because they are going to be having a lot of layers in the metabolism in your veins and in your arteries, mainly in your arteries, sorry, and it's going to decrease the radio or the diameter where the blood flows. So your heart is going to need to pump more blood, need more pressure. That's why you are increasing your pressure, because you need more force in order to pass and to go in terms of delivering all the nutrients and the oxygen to your body and to your brain, of course. And HDL is another lipid, or is another lipoprotein that is high density lipoprotein. And this one helps to remove these kind of cholesterol and triglycerides that are just stuck or stick in the walls of your arteries. So that is the one that is going to allow to remove all of this bad cholesterol. So if you don't have a good amount of this HDL, if your HDL is lower and you have high triglycerides, you have more chances of having also the low density lipoprotein, LDL, that is also going to be cluttering your arteries. So this is also going to have, as an additional action, an increased fasting plasma glucose levels, thus easing the development of cardiovascular diseases. As you can see, it is a complex mixture of many diseases in this metabolic syndrome. And these are the ones that are more common right now. We have an spiking epidemic of these kind of diseases due to the collateral damage of this pandemic season. So what is going to happen with this metabolic syndrome? It is quite an epidemic right now, since it has an overall prevalence of around 25% in adults with age over 20 years and over 30% in 50-year-old subjects and over 40% in subjects with age 60 years and above. So we are almost reaching half of the population being affected by this metabolic syndrome. So as you can see, it is extremely common. This is very important, since this metabolic syndrome is strongly associated with the development of diabetes, hypertension, as I mentioned, cardiovascular disease, and a lot more causes of mortality. So this metabolic syndrome, or MS, we are going to mention it shorter, represents in fact a systemic inflammatory disease associated with the release of inflammatory cytokines and the presence of endothelial dysfunction and oxidative stress, thus easing the development of cardiovascular diseases or disorders. So what is happening with these inflammatory effects all over your body? Your body is feeling threatened by this inflammatory state and is going to release these kind of cytokines. These cytokines are secondary messengers that are going to give the signal to your body that you are in danger. So meaning these cytokines are increasing the inflammatory symptoms, and you are going to respond with oxidative stress. And this oxidative stress is going to cause a lot more damage. And also aging. That's one other factor that is going to be accumulating to the whole bunch of diseases. So it is very important that we understand why uric acid is uncovering all these metabolic disruptions. Uric acid levels are often higher than normal in subjects with this MS, and elevated uric acid concentrations have been linked to the pathogenesis of early onset of hypertension, and they predict blood pressure elevations, body weight gain, and hypertriglyceridemia. So that's the increase of the triglycerides. Moreover, high uric acid or high UA concentrations commonly precede the development of insulin resistance. Why? We are going to get there when I explain the diagram of why we are developing this insulin resistance. Mainly, it has to do with your hormones. Both cross-sectional and prospective studies show that uric acid levels predict an increased risk of MS or metabolic syndrome. At the best of our knowledge, no study investigated the possible role of this metabolic syndrome in easing the development of hyperuricemia. Carotid intima thickness is another factor measured by ultrasounds, and it is considered a marker of early atherosclerosis. So this is the thickness that your one of the main arteries is going to be giving us a reference of how clean your arteries are or how narrow they have become due to the fats that are surrounding the walls. So this test is also a predictory test for many people that can have these symptoms of atherosclerosis, and also it is a predictive factor for having a heart failure. The aim of the study was performed in a cohort of 811 healthy, overweight, obese subjects. Otherwise healthy means that they don't have any other factor in addition to the overweight or the obesity, without overt atherosclerosis or without any other cardiovascular disease, and not using any kind of drug. And they were used to determine the relationship among uric acid and the metabolic syndrome, or the single components of the metabolic syndrome and early atherosclerosis, assessed by means of this test of the carotid artery thickness, or the test is going to be called CIMT. In particular, this study was addressed to evaluate the possible independent role of metabolic syndrome in influencing the uric acid levels. We decided, the people that developed the study decided to select overweight and obese subjects, since those individuals have the tendency to have higher levels of uric acid, as well as serum uric acid concentrations, which are able to predict subsequent weight gain. Subjects under the study were enrolled from January 2011 to December 2016. So it was 5 years, the follow-up of these patients at the outpatient clinic of clinical nutrition of the Department of Biomedical Sciences and Human Oncology in the University of Bari. Patients were referred to the clinic with the aim of improving the quality of their diet and or losing weight. Those were the options. Subjects were enrolled consecutively at the first visit, whether they show a body mass index above 25 kilograms per square meter, and they showed no clinical signs of any disease and did not take any kind of drug. As I mentioned, they are healthy obese subjects. Each subject underwent to the evaluation of the anthropometric measures, which are measures of your skin and how it has become also flaccid and also expanded. And they underwent blood samples and the test of CIMT, the test that measures the cleanliness of the diameter of your carotid. So they excluded the subjects from the evaluations with one or more of the following criteria, so that you can understand that this study was very clean in the aspects of just getting the people that had an overweight or obesity, but excluding any other factors that may interfere with the correlation that they wanted to look for. The number one criteria was age less than 18 years. The secondary criteria was secondary obesity due to endocrine or genetic syndromes different from the disorders. The number three was personal history of cardiovascular disease, coronary atherosclerosis responsible of cardiac angina or angina, acute myocardial infarction, and revascularization, stroke, or transient ischemic attack, or peripheral artery diseases. Number four was the presence of conditions that could favor the development and progression of atherosclerosis, such as chronic kidney disease, obstructive sleep disorders, or other systemic inflammatory diseases. And the number five was the presence of an active infective and or neoplastic disease. So on the basis of these 811 subjects, 239 were males and 572 were females. So that's 29% of males and 70% of females, with a mean age of 39.5 years. So the presence of the metabolic syndrome was defined according to the International Diabetes Federation. And the criteria are: the patients were considered as having metabolic syndrome, whether they had central obesity, which is the waist circumference, and moreover, these subjects were divided in 5 classes on the basis of the presence of only 1, 2, 3, 4, or all the factors characterizing the metabolic syndrome according to the above definition. 255 of the 811 subjects under the study, 31% of the whole population were affected by metabolic syndrome. So look at the statistics. They make, or they are perfectly correlated with the whole population and the whole statistics that we have almost in US. Also, they are also representative of Mexico, and they are also representative of many countries that have these kind of spikes of diabetes or cardiovascular diseases. And which were the results, or what can we start learning from this uric acid? The concerning possible role of high uric acid in inducing the development of metabolic syndrome have raised some hypotheses in terms of where do we start linking the kind of action. The pro-oxidative action of uric acid may in fact accelerate adipose tissue formation and contribute to insulin resistance through uric acid induced decrease of endothelial nitric oxide synthase and nitric oxide production, thus reducing the glucose uptake in the skeletal muscle. So this is the very important link. When we decrease this nitric oxide production, the uptake of glucose in the muscle is not properly functioning. So your glucose stays in the blood, and that's gonna raise the levels, and your insulin is going to be released, but it's not going to be working because you have too much glucose. So the effect of this uric acid on insulin resistance may explain its association with hepatic steatosis. What is this? This is the fat that is surrounding your liver, and a common condition in central obesity also. Insulin resistance enhances hepatic free fatty acid uptake by inducing peripheral lipolysis, and the consequent hyperinsulinemia accelerates hepatic fatty acid synthesis and decreases hepatic production of apolipoprotein B100, which is required for triglycerides release. So what is happening here in simpler words? Your lipolysis, so the oxidation of your fatty acids is not working, and it is disrupted because your signals, your metabolic signals are confused, and you also have raised the levels of glucose in your blood because your muscle cannot uptake the glucose due to the secondary effect of nitric oxide. And you are also affecting proteins, apolipoproteins. These apolipoproteins work as Ubers that are going to take the fatty acids to the different tissues throughout your body. So if these apolipoproteins cannot be linked to the lipoproteins particles and transport all of these fatty acids, they are going to stay and they are going to create these low density lipoproteins, and they are going to start cluttering your arteries. So this is what happens. And you are also increasing or accelerating the fatty acid synthesis. So you are producing more fatty acids. You are not oxidating the ones that you already have. and you cannot move them because you don't have enough transportation systems, or you don't have signals for the transportation, which are the ApoB lipoproteins. So it is a whole mess. Imagine that you live in a big city and there are 3 or 4 freeways closed due to a major rain, and there are no cabs, there are no Ubers, there are nothing due to the chaos of the rain. So what is going to happen? Many of the people that has to be transported to their homes are not going to be able to arrive there. So they are going to be crowding all the streets, and they are going to create more traffic. So, and also, as they have to close these 3 or 4 freeways, it's going to be a whole traffic mess that is just due to the rain. In this case, the rain is the uric acid elevation, which is going to create these different major symptoms inside of you. You are not going to be able to oxidize your fatty acids. You are producing more fatty acids. You are not transporting your fatty acids, and you are not able to uptake the glucose by your muscles. So it is a whole mess inside of you. Now, what happens with this test? The CIMT test of your artery, your carotid artery, represents a useful and non-invasive tool for the detection of early atherosclerosis, as well as of smooth muscle hypertrophy or hyperplasia. And it is also widely known that the risk of cardiovascular diseases runs in parallel to the increase in the CIMT value. So if we perform this test, in addition to many other biochemical tests that are going to give you the levels of glucose and the levels of your lipids, you are going to be more certain of what is coming for you, and you can prevent many of these chronic diseases and many of these major disruption of metabolic signals. And according to previous studies, also, age, blood pressure levels, and the presence of metabolic syndrome were significantly associated with CIMT values, emphasizing the role of metabolic risk factors in favoring the carotid and of the intima media thickening test. So, what are the conclusions? The study that they perform in those groups of obese subjects or overweight subjects without other diseases and not taking any other drug were able to didn't show hyperuricemia just by the overweight, but higher serum uric acid level may predict the risk of metabolic syndrome. Moreover, the results suggest that the uric acid cannot be considered a risk factor for early atherosclerosis, at least assessed during this CIMT test. So it is not a correlating factor to have uric acid elevation to the risk of atherosclerosis or to the risk of the metabolic syndrome per se. But if you have additional factors and you have a raised level of uric acid, then you can develop this metabolic syndrome, or you can start developing diabetes or cardiovascular disease or any of these chronic disorders separated. So that's what is happening. Now, we are going to go beyond, and this is the difference in season 4. We are going to go for more science in many of the episodes, and this is not an exception, of course. So I'm going to show you what is happening in terms of the metabolic pathways. What is happening here? Let's analyze this. And this is the beauty of biochemistry and how you can understand your body just by understanding what is happening. So this is the uric acid metabolic route. What is happening? It can be affected by many factors. Which are the main factors? Alcohol intake, insulin resistance, fructose intake. Pay attention to this, fructose intake, or purine intake. Where do we have this purine intake? We have this purine intake in red meats, in dry beans, in also an excess of protein in our metabolic, or also just because we are doing high intensities of exercise, or we elevated the kind of exercise that we are doing. So that's why it depends a lot from where the uric acid is being elevated. We have to pay attention to this because it is not the same being lean, not having any other additional factors such as your glucose level or your lipid levels, and having uric acid elevation. That can be, if it is not too much elevation of your uric acid, that can be even protective, as we mentioned at the beginning of the podcast. But if we have additional factors such as these lipidemias, glucose elevation, and we also have overweight and obesity, then we are developing all the conditions for the metabolic syndrome. So what is happening here? The pathways that are going to help us and that are linked to this uric acid metabolic route are linked to the sugars metabolic pathways. This is one of the major pathways, which is glycolysis. And glycolysis is going to produce one of the major components of your nucleotides, or the nitrogen bases. This is the sugar that forms the nitrogen bases of your RNA and your DNA and your ATP also. So that's why you need it, because it is extremely important to have this. This is the energy of your cell. This is also energy of your cell in other kind of metabolic pathways, such as the Krebs cycle. So pay attention, because if you don't have these two, they are becoming affected due to the metabolism of glucose. And the metabolism of glucose is affected due to insulin resistance and due to alcohol intake. So fructose, it's another sugar that can't be metabolized by the main pathways of this glycolysis. So it has to suffer a different transformation, which is increasing the stress of your liver. By increasing the stress of your liver, it is working overtime, because your liver is processing mostly everything from your food and from many of the things that you are consuming, including supplements or medications. So you have to take care of your liver. And this pathway of fructose is going to produce glyceraldehyde 3-phosphate. So the accumulation of this is going to produce an excess of triglycerides. And that's what starts cluttering the arteries. That's one of the reasons. So now, if we go into the metabolism of these purine nucleotides, and we have a problem because we have a saturation of the pathway due to the alcohol intake or the insulin resistance or the affected glucose metabolic pathways that can be overloading your body with glucose, then what is going to happen? This enzyme is not going to work properly, and the uric acid, it's going to be formed but cannot be passed or metabolized to the glyoxylic acid and urea, which is the way that your body is going to release the nitrogen from your body. This molecule, urea, is the main one that is going to carry the nitrogen out of your body. So if you are accumulating this uric acid due to the saturation of the work of this enzyme and the disruption of the sugar metabolic pathways, and also an increase in meats or nitrogen food, then you are contributing with many factors. And this is what happens inside of your metabolism. So this is how you can understand that you have to start applying changes in terms of reducing the alcohol intake, reducing the consumption of sugars, mainly the ones that are more toxic, which is fructose or any other artificial sweetener, because the artificial sweeteners are going to indirectly accumulate and produce disguise mechanism, let's call it like that, in your channels of glucose, and you are going to feel that you are having an hypoglycemic period of time, which is not true. This is just an indirect effect of the artificial sweeteners, because when they attach to the membrane, the effect on the glucose receptor, which is right beside it, it's going to pull the glucose from the blood for a moment, and it's going to create a momentary hypoglycemic episode. But this is not what is really happening. It is just an indirect effect, and it is just very momentaneous. So if you are consuming an excess of these artificial sweeteners, you can also affect many of these pathways and start developing insulin resistance as well. And what else can you do? Reducing the content of protein that you are having, probably reducing a little bit, or just for 2 weeks or a month, the consumption of red meats or the consumption of any other food that has a lot of high content of nitrogen. And you can start to exercise, but not in a very intense way. And if you are just doing too much exercise and you are consuming proteins or more protein, then what you can do is just reducing the amount of protein and reduce a little bit the amount of exercise, amount of intense exercise, so that you can regulate again your metabolism and start lowering the levels of uric acid. Now, What is happening here? This is more a molecular level effect, but it is extremely important for you to understand, because this is what happens at the molecular level when you have an excess of metabolites, such as these ATP or monosodium urate crystals, MUC. This MUC is signaling these receptors in your cells that is going to create an action of releasing potassium from your cells, which can lead you to having cramps, and you are going to release compounds of reactive oxygen species, which are going to create also the production of this interleukin 1, which is an inflammatory response that occurs via the inflammasomes and have been demonstrated to be linked to the onset and progression of diseases, including gout, atherosclerosis, and non-alcoholic steatohepatitis. So what is that? That you are having an inflammation of your liver due to the fat that is surrounding it and making more stressful the environment for your liver in order to start producing and continuing with the metabolic pathways. In your liver, there are more than 1,000 metabolic pathways that are occurring every day at all times. So you have to be very careful not to affect your liver. And also, this is very important because these reactive oxygen species, not only are they producing these inflammatory cytokines or inflammatory signals, but they are also producing aging inside of your cells. And you are also releasing potassium, which is not good for many of metabolic pathways, because potassium is another very important mineral that you need in order to properly work in terms of your enzymes. So this is all of the factors that we are having in terms of our metabolism. So as you can see, if we understand how our body is working, if we understand the relationships of many of these markers that many times we don't pay attention to them, and we don't even go to check our blood and how the levels are, more now than ever, we need to do it, because we suffer 2 years from a sedentary lifestyle, or we change the lifestyle that we have in terms of not moving so much as we used to, in terms of being more in the screens, in terms of being more stressed because due to everything that happened that disrupted many of our areas of our life. So all of these factors, in addition to the face mask that is also interfering with the oxygenation of your blood, is going to create a disruption in your metabolic pathways. So just go and check your levels just to see how well you are internally. Thank you very much for paying attention, and welcome to season 4. If you like this episode, if you think that I help with information that is important, please help me to move this episode and give me a like, a comment, something that helps the algorithms to start activating and promoting this kind of information. Thank you and have a wonderful day. Bye.